Okay, so we'll go ahead and just pick up right where we left off from earlier this morning in class. As I mentioned in class, we definitely have covered the most of the complex content from this chapter together in class today. So I just want to finish up with the rest of the functions of the liver, talk a little bit about the gallbladder, the functions of the pancreas, and then finish up with some aging considerations regarding digestive function. So, in talking about vascular and hematologic liver functions, remember we've already discussed the metabolism of bilirubin, the secretion of bile, the circulation, blood circulation through the liver. So we're going to pick up here with vascular and hematologic functions of the liver. So because of its extensive vascular network, which we've talked about already, the liver can actually store a large volume of blood. Not only does it store a large sort of reserve or reservoir of blood, we talked about its bacterial and foreign particle removal. We know that we've talked about when we talked about the circulatory system that it synthesizes some clotting factors to help with the stoppage of bleeding. It produces bile, it metabolizes fats. So let's talk specifically about a couple of the different substances that get metabolized in the liver. The first one being that of metabolizing proteins. So in the liver, amino acids are converted to carbohydrates by removal of ammonia, the NH3. And remember that ammonia is converted to urea by the liver and passed into the blood to be excreted by the kidneys. When we talked about the renal system, we discussed how ammonia and urea, more specifically, is sort of a byproduct of cellular metabolism. And so this is where that process sort of begins, is when the carbohydrates in the cells are in the blood are broken down into, I'm sorry, the amino acids are converted to carbohydrates and by removal of that ammonia. The other thing that we certainly have to discuss, the other big one from this slide that I want to discuss is the issue of metabolic detoxification. We mentioned this already in class a little bit, but I just want to say a little bit more about it here. The liver alters the chemicals like drugs, foreign molecules, hormones, etc., to make them less toxic or to at least make them less biologically active in the cells. And so what happens in the liver is that it diminishes intestinal or renal tubular reabsorption of those potentially toxic substances and facilitates their intestinal and renal excretion. So things like alcohol, barbiturates, amphetamines are metabolized or detoxified in the liver, preventing excessive accumulation and adverse effects of those substances. Ironically, though, the problem is that end products of metabolism, or I should say, in the end products of metabolizing and detoxing some of these substances the end products can actually be toxic as well, and can damage the liver's ability to function. So when we're talking about like alcohol and things like that, some of the metabolites from metabolizing and detoxifying that alcohol are actually just as toxic and can still damage the liver's ability to function. So it's sort of an ironic sort of juxtaposition there between the metabolic detoxification of some of these drugs and alcohol can still yet be toxic because some of the byproducts are toxic. And we'll talk about that more on Thursday when we talk about the alterations and some of the effects that alcohol has on the liver. Okay, so now we're going to move to a totally other organ, and that is the gallbladder. Pretty straightforward organ. It's a sac-like organ that lies on the inferior surface of the liver, so underneath. As we mentioned already in class today, the function of the gallbladder is to store and concentrate the bile that is being secreted by the liver between meals when the bile is not necessarily needed in the small intestines. The reservoir the max volume that the gallbladder is able to hold is about 90 milliliters. And interestingly, so the gallbladder is filled in between meals and it begins to contract 30 minutes after eating under the influence of the vagus nerve and some other hormones like cholecystokinin and motilin. Basically what this does though is it forces bile into the duodenum through that major duodenal papilla that we talked about earlier in class. So that's where the bile goes in. That's also where some of the where the secretions from the pancreas goes in as well. But that's really all I necessarily need you to know about the gallbladder. It's basically just a reservoir for the bile that's basically made and produced by the hepatocytes in the liver. So it's just a place for the bile to hang out until it's needed after eating, and then get secreted and pushed out of the gallbladder within about 30 minutes after eating. Okay, and then the last structure or organ that we're going to talk about regarding the GI system is the pancreas. And we're going to specifically talk about the exocrine functions of the pancreas, because as I mentioned, we discussed the endocrine functions of the pancreas earlier this semester. So the structure. The exocrine pancreas is composed of acinar cells, or acini is the plural, and networks of ducts that secrete enzymes and alkaline fluids to assist in digestion. There's a pancreatic duct where these secretions get drained into, and this duct is what empties into that common bile duct and then into the duodenum, as we mentioned already, where it all gets dumped in to the small intestines. Because eating stimulates the flow of pancreatic juice, the juice is most alkaline when it needs to be, which is during digestion. So the alkalinity or the pH can actually change and fluctuate a little bit here and there regarding the pancreatic juice, but certainly most alkaline during digestion when it needs to be. And again, this just sort of shows you the structure of the pancreas, that it lies sort of kind of right underneath the stomach, because the stomach would sort of be up here, but it lies right in the fold essentially of the duodenum, and it empties right into through the major duodenal papilla right here into the duodenum for aid in digestion. Okay, so it releases sort of secretions, and it releases enzymes. So you see the substances and the electrolytes that it secretes on the left side, and then on the right side you see the enzymes that the pancreas secretes. The trypsinogen, that category basically is used for protein digestion. The trypsin inhibitor prevents activation of proteolytic enzymes while they are still in the pancreas, so it sort of just makes sure it ensures that some of those things like trypsinogen and those other enzymes that digest protein, make sure that they don't necessarily get activated until they actually reach the small intestines. And then just kind of FYI, the pancreatic alpha amylase breaks down carbs, and the pancreatic lipase breaks down fats once it reaches the small intestines. So these two, amylase and lipase, are two big indicators, enzymatic indicators of pancreatic function. And in the ER, when someone comes in with sort of a vague, severe abdominal pain that we're not really sure what's going on, oftentimes amylase and lipase are a very common lab that we would draw in the ED for abdominal pain to make sure that the pain doesn't have something to do with inflammation or irritation of the pancreas, like pancreatitis or something like that. So just kind of a clinical example to give you regarding these enzymes, and we certainly look for those clinically when someone's complaining of abdominal pain. Okay. And then the very end, like I said, I always try to give some type of consideration regarding, how that particular system changes with age. So we're going to just do a couple brief minutes here regarding aging and the digestive function. You can see that tooth enamel and dentin can actually wear down, teeth are lost, there's increased incidence of periodontal disease and gum recession. There can be changes, osteoporotic changes to the bones in the jaw, actually. So this slide has more to do with issues that might happen with the sort of esophageal mouth phase of digestion, as opposed to this second slide being maybe more toward more of the secretion and motility issues. So number of taste buds decline, sense of smell diminishes. The problem with those two, number of taste buds declining and the sense of smell diminishing, will then obviously, because you don't have that satisfaction of eating, will oftentimes decrease older people's appetite. They just don't feel as hungry. They're not sort of as excited by food, which can certainly be a problem when you're talking about elderly patients with failure to thrive and things like that. They just have a decreased eating drive. They have a decreased appetite. They'll also see changes with salivary secretion decreasing, and they actually do have decreased esophageal and gastric motility, and therefore issues with in decreased gastric motility and things like that. So. Okay, well that is basically it. Like I said, we really didn't have all that much more to cover from this morning, but I just wanted to be able to do it formally in the voiceover. As mentioned, on Thursday we'll dive into alterations in digestive system. Thank you very much. Have a good week.